Hi guys, hope so you are fine. Now we are going to start sound waves part 2. Hope so already you have completed part 1 and you have written all the notes to your notebook. This video will show you the application for the sound waves and as well as pitch and loudness. So pitch and loudness also you need to write it down to your notebook.
Hello and welcome to this chapter on hearing sound. Very apt given the nature of this recording. Without sound waves there'd be no bird song, no music, no whistling wind and no rumbling vibration of traffic.
Right.
To quote the French composer Pierre Schaeffer, sound is the vocabulary of nature.
Vocabulary of nature.
The mechanism by which the human ear detects sounds is a fascinating one. But before we delve into it, we need to understand what sound is.
What really sound is?
Have you ever been outside watching fireworks or at a loud concert? The vibrations you feel and hear are the same thing, sound. Sound waves travel as vibrations in the air. Molecules of air are pushed backwards and forwards very quickly, forming a wave of compressions and rarefactions, which can be thought of as squashes and stretches.
So write
this kind of wave that vibrates along the direction of travel is called a longitudinal wave.
Right.
This is in contrast to water and light waves, which vibrate from side to side.
Fantastic.
And are called transverse waves. Trans meaning across.
Across.
You can see these vibrations if you watch a speaker or twang a ruler. The bigger the vibration, the louder the sound, which is why we can feel the very loudest of sounds with more than just our ears.
Vibrations can be at any frequency, but we only tend to class them as sound if they are between 20 Hz, or cycles per second, and 20,000 Hz. This is the range of human hearing. Some animals have ranges above this called ultrasound, which can be heard, for example, by bats and dogs. And some have ranges below called subsonics, which are used by whales to communicate over long distances.
Right.
In addition to this great range of frequencies, sound waves are really fast.
Really fast.
They travel in air at 343 meters per second,
Different books.
1,230 kilometers per hour, or 767 miles per hour.
That's great.
To put that into context, only one car has ever gone faster, and that was powered by a jet engine.
Oh.
It's over 36 times faster than Usain Bolt, the 100-meter runner.
Usain Bolt? So Usain Bolt is a human being, and he's the world's fastest human being. He can run 100 meters within 9.47 seconds. That means you just start your count 1, 2, 3, 4, 5, 6, 7, 8, 9. And Mr. Usain Bolt traveled 100 meters. So he's the fastest man inside this earth till now. Hope so you can break his record. So 36 times faster than this Usain Bolt. What? The sound wave.
So we now know about the waves themselves. How do we turn these into signals that our brains can understand?
Yeah, this is important.
The vibrations are channeled into the small auditory canal by our ears, which is why they're on the sides of our heads. They serve an important purpose. The vibrations of the air travel along this canal to the eardrum, which vibrates with the air, causing the small bones in the ear, called the hammer, anvil and stirrup, to vibrate in turn.
Right.
These bones help to amplify quiet sounds and pass on the vibrations to the cochlea, a thin coiled tube filled with liquid. Finally, as this liquid starts to vibrate, it stimulates special cells, causing them to send a signal to the brain.
Hope so you understand that how our ears that is working. You can see that this is the external part of our ear, which one you can see whenever the sound waves they are coming. So these external segment, it will receive those sounds from air, vibration of air, right? So after that, this sound signal, it will go to this channel or this canal, and over here we are having 3 different types of bones, and with that bones it is going to the cochlea. And this is actually the liquid part. So the sound vibrations are coming through this liquid part, and this liquid part, it will again produce another vibration, and with that vibration it is transferring to the cells, and that cell is transferring that sound to the brain, and the brain will detect that Mr. Shahid is teaching sound waves.
All of this is happening all of the time right now.
The sensitive nature of the structure of our ears means that the large vibrations of loud sounds can damage our hearing over time. So don't listen to music or this
Don't.
recording at too loud a volume.
Right.
In summary, a sound wave is a longitudinal wave or series of vibrations back and forth along the direction of motion.
Right. So it's a fantastic, right? For the sound wave. Now we're going to learn about pitch and loudness.
Imagine it's a beautiful day and you're finished with exams. You're sat on the grass enjoying the sunshine and listening to some music.
Yay!
Have you ever wondered what makes a sound so pleasing? Well, the answer is closely linked to two aspects of sound described as loudness and pitch.
Let's go to see.
Let's look at each in turn and see what contribution it makes to our relaxing day out.
The first term, loudness, is fairly self-explanatory.
Right.
At its most basic, it's how loud the sound is, or
How
the
loud the
amplitude
sound is.
of the longitudinal sound wave. Remember that amplitude is a term meaning the size of the oscillation.
So loudness means the size of oscillation, means amplitude.
At a more advanced level, you might be interested to know that your perception of loudness is related to both the amplitude of the wave and the duration of the sound.
Great. So you need to understand, right, that the two factors it will work here.
Loud sounds appear to be quieter if they only last for short fractions of a second. Louder sounds are produced by inputting more energy into creating the wave, whether it be shouting louder, hitting a drum harder, or plucking a string harder.
Okay.
The energy is transferred by a bigger vibration.
Pitch represents the frequency of the sound. A high frequency gives a high pitch, whereas a low frequency gives a low pitch.
Great.
Rather unexpectedly, it has been found that the perception of the pitch of a sound changes with the volume of the sound. The louder the sound, the lower in pitch it can appear to be. Not by much,
Fantastic.
but enough to be noticeable. We change the pitch of a vibration by changing the length of the sound wave. A guitarist will push on a string to shorten it. A woodwind player will open a valve to shorten the instrument's tube.
Right.
A xylophone player will hit a shorter tuned bar. In each of these examples, the pitch of the note will be higher, as the vibrations are faster and the wavelength.
So pitch will be higher. On that case, the vibrations are faster, and the wavelength is shorter. So wavelength is shorter means what? The frequency that is higher. So less wavelength means more frequency, right? So pitch depends on the wavelength of the wave or the frequency of the wave, and the loudness, it depends on the amplitude of the wave.
Shorter. To make the instrument sound lower in pitch, we lengthen the string, tube or tuned bar.
Right.
But this doesn't just apply to instruments. Try this experiment for yourself. Hum the lowest note you can, rising all the way up to the highest note.
Let's go do it. Let me do. Let's start to do with me. Okay, right? Ready? Steady. Go. Like this. Hum the lowest tone you can. So hum the lowest tone means lowest tone, and highest tone. Like this. Okay. So if you like to make the highest tone, then you need to make your mouth so big to make the higher note. Note. N-O-T-E means large sound. Note means sound.
What do you feel? Can you explain it in terms of what we've met? To make a high note, you contract your vocal cords and change the shape of your throat and mouth, causing the waves to vibrate faster,
Right.
a higher pitch. To make a low note, you do the opposite.
Correct.
The exact way that these two, the pitch and loudness, combine on every note is a big part of the timbre, or overall sound, of an instrument or voice.
Yes.
The subtle variation in timbres allows you to differentiate a trumpet from a guitar, even if they produce the same note at the same time. It also allows you to recognise other sounds from cars to voices. More importantly, the way that pitches combine and vary to make music can make your day in the sun pleasurable, if they combine to make a form of music you like, or misery if they don't.
Great.
Whilst on the subject of loudness, it's best to get serious for a minute and mention hearing loss.
Hearing
There's
loss.
no way around it. Listening to loud sounds damages your hearing. In the same way that smoking will damage your lungs over time, loud noises will damage your hearing. Pete Townsend of the band The Who, which holds the record for the loudest concert ever, is going permanently deaf.
Do not listen song loudly. Do not. Look this person. He's the member of, the name of the band is The Who, and he have lost his hearing.
He's been quoted as saying, "I have unwittingly helped to invent and refine a type of music that makes its principal proponents deaf. Keep your personal stereo to a sensible level, and if you have any discomfort, then give your ears a break. Yes, even when revising."
So here we are. So if you can understand this video, that's very good. If you cannot, so just play it or watch it 2-3 times and pause it and write these informations regarding loudness and pitch to your notebook. It will be also a very good practice for your English, for your listening of English, and as well as the physics. So hope so you understand, and if you have any questions, any type of any doubt, so just feel free to ask me to the QQ group in the class time. So see you to the next class. Bye bye.